Welcome back to Data Science. This is Vivian Arana, and today we are going to look at Matplotlib, another library we have seen through NumPy and Pandas. We'll use those libraries here too, just to get some data and data structures and numerical operations. But in Matplotlib is a library which is used for data visualization. We have seen like all numbers, all data, all text, but now we probably would want to see how to display this in graphs and bars. So data visualization means all the data we have in our data structures or data arrays or series or whatever you call it, all of them being plotted in charts like line charts, bar charts, pie charts, histograms, scatter plots. So we'll learn all those different types of charts and how to display your data in a way where you can actually kind of present it to your peers or managers or whoever and kind of try to make them understand why and how your data is important, what does it mean. So first let's start with the first line plots. So let's go and create a new Jupyter notebook. I'm gonna say new notebook, and inside here now first let's go and import NumPy because I'll need that for creating some arrays. NumPy as np, and I'll also import mat, or for matplotlib you have to say from matplotlib I want to import from this particular library. I want to import pyplot, and I'm gonna name it or alias it as plt, so I can use that going forward. Next step, let's create an array. So I want to create an array of numbers. I don't want to give like 1 2 3 4, so I'm going to just create 1 to 19. That's what I'm going to do. X and Y, I'm going to say another one of range. So these are some of the things that we learned in the previous in NumPy tutorial, where we saw how you can use a range to give numbers from 1 to 19. In this case 20 is excluded, 5 to 100 with steps of 5. So it's pretty much the same numbers, that same amount of numbers that X has. Now I'm gonna use plt, which is my pyplot, and use the plot function inside there to plot a line plot or a line plot. Yeah. So plt dot show, run it. And if you see, I have a line plot here. A line plot is nothing but from one point, it kind of takes all the points here. So for example, if I want to see what's inside here, X, and if I want to see what's inside here, Y, so it will take one, it will put all of these in X coordinate. So X coordinate is here, Y coordinates are here, and it's going to plot 5 comma 1, then 1 comma 5, 2 comma 10, 3 comma 15 in this particular plot, and add it over here. Next thing that I can do is let's take the same example and add some more parameters to it. So I want to add a title to my chart. So I'm going to say plot dot title. Let's say line plot, since it's a line plot. Next I want to say plot. So if I just let me run this, you'll see it will add a title on the top. I can also add titles to labels to X axis. I'm going to call it horizontal axis. Similarly for Y, I can say Y label is vertical axis. And in this case, what happened? Oh, plt. Okay, there you go. And I have my horizontal axis label, vertical axis label added here. You can also add grids to your graph by saying plt dot grid, and inside that do true. By default it's false, and you'll see it will add grids inside my chart. Next thing that I want to do is add some properties to it. Like for example, I want to give, let me create a new one so you guys have this. For example, I can add colors to my, so by default it's blue in color, the line. I can say I want red, so this way it will create red line. I can add more like line style. I can say line style is straight line right now. I can say I want dotted line, which is this, which will add a dotted line. I can say I want a dash dot line, which is more like this. I can also add a line width, so that will kind of give more width to my line. I can say 3, I can say 30, whatever you want. It will be more thick but doesn't look good. I'll say 5. So you can add all these different parameters. I can also create if I want to add more than one lines, so let's take the parameters of y, and actually I'm going to do another point. I'm going to say y2 and say y, whatever the values of y are, I'm going to divide by 2, and I want 2 lines, so I'm going to say plot this first line, and I want to plot a y2 line. I'll say change the color to green. Instead of this, have a dotted line, let's say 3, and run this. So if you see, now I have 2 different lines on my graph. So this is another thing that you can do, which is pretty cool. What if I want to do 2 plots but in separate lines, separate graphs? So what I have to do for that is I will use something called a subplot. You can say plot dot subplot. So in particular, you can do it horizontally or vertically. So if I want to put 2 graphs next to each other, 2 plots next to each other, I'm gonna say I have 1 line and 2 plots. The first plot here, second plot here, and this is the first one that I'm drawing. And inside this, I want to use this, and let's say I'm going to use all these same properties here, but I want to create another one. Can say this is the second one, or sorry, first line, one line with 2 plots, and the second one is this plot. So it will, as soon as I plot it here, it will use it for this guy. Plot for this will create plot for this one. So what I mean by that is, if you see, I have the same line, 2 different plots next to each other, and since this is added here, I have to add it here. So this will create, so if you see what it happened here is, okay, so I guess I don't have to do this. In this case, what happened is it didn't add initially, if you saw, it didn't add horizontal vertical, so I'll have to add this here just to make sure even this guy has the title, the horizontal axis label, vertical axis label. So that's what it does. Similarly, I can change it. I can say it can be in 2 different lines, one horizontally, sorry, vertically, 2 and 1, so you can add it one below each other. So similarly, you can add multiple variables here. The next thing that I want to show you is, so this is all that is there for line plots. I'm going to go to Barplots. So for Barplots, it's more like you have key value pairs, or you have items and then values assigned to it. So I'm going to create a new parameter employee just to get some data. I have employees, Vivian, who works 5 days a week. I have an employee, John, who works 3 days a week, and I have an employee, Jane, and she works 6 days a week. So I have 3 employees. Let's look at how do I get their names. So for getting names, I'm going to call the list function, and I'm going to say employee dot keys. So since keys are these values, I'll get them. Next thing I want to say is, what are the values for these? I'm going to say list function employee dot values. So keys are these, you have probably seen in dictionary that we did before. So now once I have this, I can say plot a bar chart with names and values. When I run this, I'll have Vivian, who's working 5 days, John, who's working 3 days, and Jane, who's working 6 days here. Next, these are vertical bar charts. You can also do it horizontal, which I'll show in a little while. But if I want to add more items to it, like let's say I want to create a title for it, can say Barplot. It's similar to line plots. X label equal to employee names, plot dot y label, and y label is work days. And if I want to show grid, same thing as before, can do true, and I can say plot dot show. And in this case I have a problem, y label is not spelled properly. There you go. So my title, x label, y label, all the different parameters. If I want to make a horizontal one out of this, all I have to do is bar h and run it, and you will have a horizontal bar chart. It just all you have to do is change the parameter. Similarly, you can also give like properties to your like color. I want to change it to red, and you can have these properties added to your bar charts. The next chart in line is scatter plot. So what are scatter plots? Scatter plots are used quite a lot in data science, where you have multiple clusters of data and you want to kind of figure out the best way to get where the clusters are, or if you want to add multiple points in a graph and try to get the standard deviation line over it, or what is the formula to get prediction. So these are scatter plots are used quite a lot over there. So how do I create a scatter plot? So I have x coordinate. I'm gonna do np dot random for my y axis, because I want random numbers from, let's say, 1 to 100 with 19 items. Since we have x has already, we have created x with 19 items right on the top right here. So I'm going to use x same and create my y with random objects, and then I say plot dot scatter, give x and y, run it, and I'll have a scatter plot. And this is how a scatter plot looks like. Can take this and then say scatter plot. Actually I have this I can give more properties to it. For example, these things, these dots are called marker, so I can say instead of dots I want star, so that will put stars over there. I can change the color by just using C as red, and that is color. I can give a size, can say size equal to 50, bigger. If you want to make more bigger, 100. If you want big stars, it doesn't make sense, it doesn't, kind of defeats the purpose, but there you go. So this is how you can create scatter plots with dots or with the stars inside it. Now what if I want different types of data in my scatter plot? In that case I can, let's use this again, can add it here, and then I'll create one more parameter, call it z equal to, and again same values, but again it was, since it's randomized, both the objects will have, items will have different values inside there. And I have this, and I'm gonna write it twice. Actually I'll use this one for this guy, x and y, and for this one I'll say x and z, and for marker I will use the same dot default. Color I'll give, let's try green, and size I'll give, let's say 50, and plot it. And if you see, I have multiple different types of plots based on the values that I get. Again, if since it's random numbers, every time I run this, execute this, it will kind of add points at different places. So this is how you can add multiple types, or kind of differentiate different types of scatter plots in particular in graph. So you can kind of have two data sets and try to compare them with each other using this in the same graph. Next thing is subplots, the same thing that we did above, but for this, having side by side, I can have, let me copy this data here, and inside this I can say plot dot subplot. So same kind of idea works here. I'll say I want to have one line, in one line I'll have two subplots, and the first one is this, and the second one, so one line to the second one is this. If go here, plot dot show, and there you go, I'll have one line, two plots separately. I differentiate. So depending on what the use case is, you can kind of display it as how you want it. Next thing that we're going to look at is, so that's it for scatter plots. Next thing is histograms. Histograms, they look like bar charts, but as you know, bar charts are used for categorical values. Histograms are used for numerical values to kind of add buckets or bins, what they call it, to differentiate the data. So if I have, let's say, a data set of 1, 2, I'll just add some values, 2, 3, 3, 4, 7, 8, 5, 9, 9, random numbers. I'm just filling up this thing, and I say plot dot histogram, HIST, give X to it, and I say plot dot show. When I run it, I have a histogram displayed here. If again with any other plots, you can give it color. You can say color equal to, let's say, red. I have red histogram. If you want to reduce the number of bins, so what happens is it will probably take the data and add items to it. And if you'll see, 2 and 3 has most number of appearances here in the 2 and 3 bin, because 2 is repeated 3 times here and 3 is repeated again 3 times here. So that's what histogram does. It takes the data and puts it in bins. If I want to reduce the number of bins, I can just say bins equal to 3 and have 3. So it kind of differentiates them into 3 sets and then adds points into it depending on which. So 1, 2 and 3. So 1, how many times these things are repeated? 1, 2, 3. How many times 4, 5, 6 are repeated? 7, 8, 9 are repeated. I can kind of create 10. Doesn't make sense in this case, but since I don't have 10 numbers, 9, let's say 5. So 5 bins, 1, 2. So it will try to divide the entire data set into 5 and add the occurrences in those particular bins that it has. Again, you can add grids and all those things, but that's how you can draw histograms. Now, if I want to draw this histogram based on the previous example for flights data that I have used. If you remember in the previous video, if you're not, you can go back and check. There's flights.csv. Just make sure I save this. Python, and this is Matplotlib. What we did was, okay, so first let me import pandas as PD. Once I do that, I can get flights in pd.read csv is the function, and the file that I want is flights.csv. Let's see if it gets it. Okay, so I got the file. Let's look at some of the items. Head, so top 5. Now I have these items, so I want to display some of these, all the items, into a histogram. So for example, I want to display airtime in histogram. What I can do is I can say plot.hist, and from flights I want to use airtime, and I can set bins. I can set color equal to, let's say, green, and I can say plot.show. Do it without the bins. I have my items here, but it has too many bins here, so I'm gonna kind of try to reduce the bins to, let's say, 10, and I have a better representation of this. Since it had a lot of values, it kind of gave me that warning before, but if I do this distance, I have 10 bins where I've added depending on how much where they fit in. So this is how you can kind of take real data and add it into a histogram. Next thing that we want to see is box plots. Now box plots provides they sometimes looked as candles. What they do is they provide something called as 5 number summary. So for a number of sets, it will give you minimum value, 25%, 50%, 70%, 5%, and max value for that. What do I mean there for that? So let's create some random numbers. np.random.randint, and I want 1 to 20 and 19 numbers. I'm going to copy this 3 times. Say y and z, and I'll change numbers here from 1 to 10, so 15 to 30. I can use negative numbers, minus 10 to, let's say, 15. So this will create my 3 arrays or series. and from that I'm going to say data equal to list. So I'm going to create a data object and add all these three items into that x, y and z. And once I have that, I'm going to plot that inside a box plot data, and this is how a box plot looks like. This is the minimum value of the first item, the 25%, the median, the 75% and 100% maximum value. So that's how box plots look like, and that's how you can use it. You can just say plot dot show, just so it looks clean and doesn't give me all the extra items in there. So that's how, and every time I run this, you'll have different plots because I'm creating random numbers, so it will have different representation of that. And if you see, since I've used negative for the third one, it's going to start from here. So this is how a box plot looks like. Now there's something similar to box plot called as violin plot, because it looks like violin. And what you can do is you can take this data, you can say violin plot and show. So it looks like violin. Now if you want to show medians in this, because if you see, it just shows minimum and maximum and how it flows through it, you can also say show medians equal to true, and you'll see it will show the median of the value. So the reason it looks like violin is because this is where the data is more, and that's why median is moved here, whereas in this case this is where the data is more, so that's why the median is on the top. So this is a good way of representing your spread of your data items. So that's what violin plots are used for. Next one, and my favorite, is pie charts. Now who doesn't like pies, right? Now pie charts gives us distribution between different categorical values. It shows their percentages in it. If you don't know how they look like, let's create some. So I'm going to create different countries. I'm going to say USA, Germany, and I have, let's say, France, and I have another, let's say, population of these countries. I'm gonna just roughly say in millions, 300 million. I have no idea, so I'm gonna say 220 million, and France is 180 million. Or I can just make sure I don't have to put them in strings. Okay, so these are my countries and their population, and I can say plot dot pie population plot dot show. Now it will create a pie chart. This is how a pie chart looks like. So this, from the numbers, I can say this is USA, this is Germany, and this is France. Now if I want to display labels, I can say labels equal to my countries, and it will add labels around it. If I want to give percentages inside it, I can say comma auto percentage equal to percentage. The format starts with percentage, ends with percentage. Inside that, I want, after the decimal places, two numbers, f and then percentage. So this is how you can specify, and that will give you that. And you can give colors. If you don't want the colors that they decide for you, you can say, okay, I want red, green and blue. It's pretty much very close to what they have, but it will give me red, green and blue. Similar to this pie chart, we also have something called as donut chart, and it looks exactly same like pie. Just the difference is, when I'm creating this, I have to give a radius to my pie chart and create another placeholder, and inside this I say I have data of 1. I have colors I want is white, so I'm gonna say W since it has only one value, and radius equal to 1. So 1 radius, and this has 2 radius. So what it will do is it will create a circle with radius 2 and then radius 1 here. You can say radius 3, and you see it will be bigger. So you can kind of move around the numbers and play with it depending on what you want. So this is how a donut chart looks like, pie chart. So we looked at all the different types of chart or how you do data visualization. Till now, before this, we did how to process numerical data, how to process data structures. Now we have learned how to use those data structures and your arrays or numerical values into charts, and kind of create a project where you can demo all these items out. So that's it for libraries, and if there's more libraries, I'm going to keep on adding to this section, but other than that, these are the three major libraries that we need to learn: NumPy, Pandas, and Matplotlib. I'd say probably go over them a few times, practice, and let me know if you have any questions.